A big round of applause for Yifei and his talk about NixOS and Tailscale.
Okay, thank you guys. Hope everyone had a nice lunch. Okay, this a little bit about myself. I'm a PhD student at INRIA, and this is my side project. It's not my actual research, but they are funding my trip here, so I have to put the logos there. And I got asked why are you doing this, and free will. Okay, here I am. And a little refresher, what's a routing daemon? It's a software that implements routing protocols and exchange routing information with other routers and maintain a routing table. And in this specific talk, I'm using BIRD. BIRD is a recursive acronym for BIRD Internet Routing Daemon. And what's the problem? The problem we have is the BIRD configuration in NixOS module is text only. It's kind of hard to maintain and kind of hard to compose with other services and reuse on different servers if you reuse a lot of the same configurations. And the solution here is parameterize the text-based configuration with NixOS options. And a little prerequisite, it'd be nice if you know Nix and NixOS and some networking knowledge like systemd, network D, nftables, but IP tables also fine, and BIRD and Tailscale. Tailscale here is only used for internal routing, and you guys will know in a little bit. So a little background information: the internet gets to work because companies and individuals get resources from RIRs, and they set up routing security and import-export policies, and had on upstreams and peers. Then add the announced IP address, announced addresses to their interfaces, and then they are pingable. To get resources, usually you would go through RIRs, which means regional internet registries. There are 5 of them. Or you can get it from LIR, means a local internet registry. And for IP addresses, you can either get a direct assignment. There's a waitlist for IPv4 right now, and V6, they're just giving it out for free, a lot of them. And also, you can go with a third party. You can buy it or rent it, and for quite expensive. Or if you don't want to do the real routing stuff, you can go with DN42 or other experimental networks. To set up routing security, there are 2 sides. One is the RPKI stuff. You add ROA objects, which means route origination authorizations, which means which ASN can announce which prefixes, and they're based on X509 chain of trust. And IRR is a query language, and you add IRR objects into trusted databases like NTT, RADB. Yeah, that's simple. But you have to do it. And next up is getting connected. You either need a physical presence in a data center like HE, Cogent, or Equinix, or you can go with VPS providers that provides BGP sessions for a fee or for free. Usually there are quite a lot of them, and there is a list of it on bgp.services website. Or you can go with any VPS and use a virtual internet exchange or transit providers, and then you set up a direct connection to their router. And you can go with a lot of options. And the next step is going live. You have to set up BGP sessions with your upstream and get routes from the upstream. There are multiple options. You can go with the default routes. They only send you 2 routes, the default for V4 and V6. Or you can go with a full table. That's usually not necessary, and it's a lot of memory. And it usually takes around 250 megs for 1 million V4 routes and 250K V6 routes. And it may be the RAM usage may be smaller or larger depending on which routing daemon you go with, like FFR or any other stuff. And you have to set up routing policies, like import-export policies from your side, or you're importing from upstreams, and filtering. And if you don't want everything from upstream unfiltered, you can set up ROA filtering, you can set up IRR filterings and stuff, or some custom policies as well. And then you add the address that's within the prefix you announced to either a virtual interface or a physical interface. And the implementation for this is NixOS modules, just NixOS modules. And for RPKI stuff, we define an option under the router umbrella, and then you have RPKI.validators. And in theory, you can also add IRR filters in here, but it's not done yet. And this is simply done by providing an ID for generating the name and the remote and port number for the validator. And you also can specify the retry, refresh, and expiration time for the protocol, the RPKI protocol inside BIRD Routing Daemon. And this is the actual implementation. It's basically using Nix as a templating engine. You take the configuration you have and generate a blob of text. And the library function we're going with is the concat map string separator. And then you loop through each of the validators and add two end lines at the end. And then set up the remote and port and the retry options and refresh and expire stuff in there. This is the stuff you generate if you use IPv6 based stuff. And you also get a filter for free. This is not customizable for now except for the name. And you can refer to this filter in your later configurations. For example, if you want to use it in static import-export filter, or you can use it in the BGP session configurations. And the kernel protocol is used to export routes to the kernel. And for me, I'm using a very small VPS. It only has 1 gig RAM. If I have a full copy of the routing table from BIRD, and also I export it to kernel, it just blows up. Can't do that. So you can also go with manually adding routes with networking configurations in the NixOS options, or you can add some scripts like inside the activation process or network local setup target. And static routes is used for non-dynamic routing options you want to get into the routing daemon. And in this example, we are using the RFC IP address space for this. It's very nice. If you guys are giving talk on any of the BGP stuff, you should use the RFC documented v4 and v6 prefixes. And in here, it's also using its implementation using the concat map string separator. For BGP sessions, this is the part that gets interesting. You get a list of attribute sets where it contains the name for the session and the password for configuration validation and the type of the session. You can either have v4, v6, or you can generate both in one blob. And the multi-protocol extension can also be configured in here. You can expose your v6 routes over a v4 session, or a v4 routes over a v6 session. Both will work. And then the neighbor configuration, their ASNs and router IP addresses, and then your import and export policies. And now you've set up the BGP sessions, and you just need to add the address to an interface so you can get connected to the internet. And for here, I'm using a virtual interface for ease of management, and I'm using the dummy kernel module, and set the forwarding to true, and disable the manage foreign routes in systemd kernel configurations. If I don't set this, If you do export routes to kernel, it will be wiped if you don't set it to false. And this is the configuration for the dummy interface. It's the name, the kind, and the addresses and routing policies in there. And this is the place where you can get to add the addresses you declared onto the dummy interface. The benefits you get from using this module is you get parametricity. For example, in here, you can enable or disable configurations based on the router address you've added to your router, to your server. And the question now is, what if you have multiple upstreams? And if you have two different servers with two different upstreams, and you don't set up internal routing policies, your routes expert from one side won't be reachable from the other. So this graph shows that if this node is announcing this block with address 100 in here, 200 in here, and clients on this side will see 100 but will not be able to reach 200 because these two nodes don't know how to communicate with each other. And the solution here is Tailscale. And we are using the Tailscale subnet router feature so that they can establish a direct connection between them. It's tunneling. And how Tailscale works is they have a coordination server, and when each server goes online, and it contacts the coordination server, and so that they can help the two servers or more servers you own to create a mesh connection, mesh WireGuard connection in there. And what you get this is anycast. And what anycast is, you can use the exact same IP address on two different machines. And then clients accessing the IP address will get the lowest possible latency based on the BGP infrastructure here. And many providers already use this. GitHub Pages, Cloudflare, and Google, they all use this. It's nice. And it's mostly common in CDN and serving static content. And what I've learned from this is I don't really like setting up NAT, and it's pretty hard to debug, and we should all use IPv6 if possible. It's really easy to set up a looking glass with NixOS. You just need to specify the socket, the Linux socket on your machine, and then just pass it to BIRD LG NixOS option, and then you get a website for free. It's pretty nice. Or you can export the full table to bgp.tools or other network operator groups. They all serve that for free. It's pretty nice. And when debugging, I found these tools pretty helpful and really nice. And shout out to pin.sx. They have a very nice website, have about 100 nodes, and you can do pin and MTR directly, and shows very nice UI. And one other problem I had with Tailscale is they eat the entire CGNAT range. If you want to peer with someone over virtual link, and they happen to use a IPv4 address on the CGNAT range, you won't get traffic through it. So the solution here is either you guys set up the vextend over IPv6 addresses and don't use IPv4 entirely, and then do the multi-protocol to send your v4 routes to the v6 session, then it will work. That's Tailscale, and there has been a long-standing issue there since 2021. It's still not resolved, so hope that it gets fixed pretty soon. And as a closing remark, it's possible to run your own validator, like specifically IRR ones. And I also plan to upstream my contribution in this project to Nix packages, and that's about it. I'll take questions.
So Thank you for the talk. Are there any questions? We have 2 mics now, so we should be faster.
Yeah, thank you for the talk. I have sort of a bizarre question. So since you are modifying services.bird, as far as I'm getting in your module, do you consider adding other dynamic routing protocols like link state protocols, let's say, or something else at least, or maybe RIP as a metric base?
So I have a alpha implementation, which I plan to implement all the BIRD protocols in there. And there you go.
Any more questions?
I didn't quite get why you need the Tailscale at all if you can, if you have your BIRD already set up. Like that's the most complex part that Tailscale usually does for you because you don't want to do the routing, but you could just have a regular WireGuard with BIRD running and then do IP packet forwarding. I don't see why the Tailscale here is necessary.
Yeah. So you for sure can use other modules like WireGuard, VXM, or whatever you want. And Tailscale is just used here because it's simple. It's very simple and easy to use for me. And if you want to add another node to your system, and you don't want the node to have an upstream, so with Tailscale, you can just use the subnet router feature to advertise that specific address and add a dummy interface on that machine. So all the traffic will go through that machine and can be reachable via the internet. It's convenient for me.
I see.
Yeah.
Questions? No? Then thank you again for the great talk. Give him a round of
Thank you.
applause.